We solve the quadratic equation by using the square root property. Now the only time we can use this method is if we have something squared. Now remember, I previously told you that if I had the square root of, let's say 7, and I squared it, what does that mean? That means the square root of 7 times the square root of 7, because we squared it, 2 of them. The square root of 7 times the square root of 7, they're both underneath the radical, so I can multiply them. That will give me the square root of 49, and the square root of 49 is just 7. Would you look at that? So the square and the square root just cancel each other out. So you don't need to do all that work. It's like when I used to have, let's say 3x equals 12. What's the opposite of multiply? How would you solve that? Well, the opposite of multiply is divide. You would divide both sides by 3. Why did you do that? To get x by itself. So the opposite of taking the square root is to square something, or vice versa. One more fact I want you to learn. If I have x squared is equal to 81, do you believe that this could be 9 squared? Is that true? Is 9 squared 81? Yes, 9 times 9 is 81. But wait a second. Could this also be negative 9 squared? Negative 9 times negative 9 is also 81. So, if I have x squared or something squared and I tell you it's equal to 81, you have to know that this x, whatever's inside this parentheses, in this case it's just x, you have to know that it could be positive or it could be negative. So whenever I choose to take the square root of both sides to solve for x, I am going to have to remember to put plus or minus. So let's get to work. We have the problem x squared is equal to 25. I have an x squared, but I don't see an x to the first or something. I have just a squared item. I can use the square root property. Get the squared item by itself. It is by itself, but I don't want x squared. What are we supposed to look for? X. Solve for x. Just x, not x squared. What's the opposite of x squared? I'm going to take the square root. But if I take the square root of the left side, I have to take the square root of the right side. I don't care what you do to each side, but they're equal. So you do the same thing to both sides. So the square root of x squared. The square root of x squared. Hopefully know your radicals. That is just x. On the right side, the square root of 25 is 5. But what did I do? I took the square root of both sides. I had something squared. So I took the square root of both sides. But when I have something squared, I have to remember that thing inside there could be plus or it could be minus. My solution set, my answer is it's positive 5 or it is negative 5. Let's try another one. I'm solving this quadratic equation. Can I use the square root property? Yes, I can, because I have just this one thing squared. I don't have an extra variable somewhere. I just have this one thing. Just the one thing squared. That is not x. That is not 5. That is x plus 5. It's a binomial squared, but it's something squared. How do I get rid of that? I don't want something squared. It's confusing me. I'm trying to get to x. Well, I'm going to choose to take the square root. But if I take the square root of the left side, I have to take the square root of the right side. When I take the square root of something squared, they cancel each other out. I have left just whatever is underneath there. In this case, x plus 5. On the right side, the square root of 17. I can't do anything with that, so it's just the square root of 17. But don't forget, if you take the square root of both sides, you have to put the plus or the minus. The plus or the minus goes right here. This is where the plus or minus goes. Is x by itself yet? Not quite. X has 5 over here. 5 is being added. Just look at the equation. Tell me. You see 5 is being added. What's the opposite of adding 5? To subtract 5. But if I subtract 5 from this side, I have to subtract 5 from the right side. On the left side, I have just x left. Now on the right side, I can't put 5 and 17 together. 5 is not underneath the radical. And I like to leave the radical at the end. So I'm going to write negative 5 plus or minus radical 17. So my answer is negative 5 plus radical 17 or negative 5 minus radical 17. Okay, last problem we're going to do by using the square root property. The question is, can I use the square root property here? Yes, I have x squared, but I don't have an x to the first. I just have this thing squared, but no x to the first. So get the item by itself. I will start by subtracting 5, but if I subtract 5 from this side, I have to subtract 5 from the right side. On the left side, I have 3x squared equals, on the right side, 86 minus 5 is 81. Is the x squared by itself yet? No. Don't take the square root yet. It's not by itself. You see 3 over here with it? This is where people want to take the square root. You have to get the squared item by itself. The 3 is not squared, only the x. Get rid of the 3. I will divide both sides by 3. X squared is equal to 81 divided by 3, 27. I'm almost done. Now x squared is all by itself, so I'm going to choose to take the square root of both sides. And if I take the square root of the left side, I have to take the square root of the right side. The square root of x squared. Remember, the square and the square root, they just cancel each other out. Whatever's in there, that's what you have left. Don't forget your plus or minus. Whenever you take the square root of both sides, you have to put the plus or minus down there. The square root of 27, I could break that down. What is the square root of 27? Break it down to 9 times 3. And the square root of 9 is perfect. 9 is perfect. When it comes out, it's just 3. And I can't do anything with this radical 3. It just hangs out. My answer is positive 3 radical 3 and a negative 3 radical 3.